Today's show's hotter than this twin turbo. We're going to talk about fuel injection, supercharging, and turbocharging next on Tech Garage. Welcome to Tech Garage, presented by Advance Auto Parts. We got a great show. We're going to take you through fuel injection. I'm talking carburation all the way through direct injection. We're also going to take you with us and do some diagnostics and troubleshooting on this truck right here. And later, forced induction, superchargers and turbochargers. Let's get started with the basics. Now, we're all pretty familiar with carburation. Carburation sat on top of the engine and it used engine vacuum and just pulled the fuel through it down into the cylinders. You can see the throttle bodies right here. When the throttle bodies open and close, the vacuum would pull it down. Actually, carburation used a fuel pump that looked like this. It was strapped to the side of the block and it pumped by the cam lobes, or you could have had an electronic one in line, but the point is here, it makes about 3 psi of fuel pressure. Then there was throttle body injection. Looks just like a carburetor, except it uses a fuel injector. You can see the fuel injector here located right up on top. The computer would control that and it would allow the fuel to go into the cylinder, but it sat on top of the intake manifold just like a carburetor. The fuel pump's right here. They started to locate them in the fuel tank. The fuel pump itself puts out about 13 pounds a square inch of pressure, but be careful. This fuel pump is going to look just like the sequential multi-port fuel pump, but this one puts out 13 pounds of pressure, and the other one puts out about 40 to 60 pounds of pressure. Next, we'll look at the multi-port and sequential fuel system. Multi-port injection or sequential fuel injection looks similar to this. Come here and I'll show you. This is actually the fuel pump. Now the fuel pump's located in the tank, just like a throttle body injection, but this fuel pump's putting out anywhere from 45 up to 60 psi of pressure. Then it comes up here, and it's gonna flow through the line. Now, a lot of times, you may have a fuel filter in that line going to the injectors. You can see the fuel filter right here, and if I open up, the media is right there that it actually goes through. Then what it does, it comes down to the fuel rail. And as it passes through the fuel rail, it's going to go all the way out to this fuel pressure regulator. Now the fuel pressure regulator is there to back up fuel pressure. If I'm in wide open throttle, I need more fuel pressure. The absence of vacuum will close a valve here and it'll allow the pressure to build up. If it's at idle, not so much. I don't need that much fuel pressure. So what's going to happen is it's going to allow it to return to the tank right here. Now you could have a returnless system. It may just pump through in the tank, but somehow it's going to regulate that fuel pressure. Now with all these sensors on the board, the computer is going to determine how much fuel the car needs. That's called post-width modulation. If it needs a lot of fuel because it's a lean condition, it's going to open up those injectors about 80% of the time, 80% on, 20% off. Now, if the car is really, really rich, the computer is going to tell the injectors to go ahead and lean out the car. And what it does there, it turns them on 20% of the time and off 80% of the time. And that gives you that perfect 14.7 fuel mixture that your vehicle needs. Now, I can show you this in action. I can come over here and I can start the board. And what's going on is it's actually pumping the fuel around. And if I reach over here and I open up the throttle plate, what's happening, it's mixing the fuel delivery to match the air. You can see it's pumping more right there. That would be 80% time on. And when we're idling, that would be about 20%. But that's a good look at the fuel injection system and what it takes to get it in there properly. Next, we need to look at direct injection. Direct injection, a new technology when it comes to gasoline engines. It's been around for diesels for years, but we can take a look at our direct injected engine and see how it works. Look right here. We actually have a cam lobe, and my cam lobe is driving the high pressure pump. That's where it all starts. Now prior to that, everything's the same. You still have a fuel pump in the tank, and the fuel pump's going to deliver 40, 50, 60 psi up to this point. Now at this point on, everything changes. Here's my high pressure pump. As this lobe right here turns, it's going to develop that high pressure with the use of this pump, and then it's going to deliver it through these steel lines. Now notice I said steel lines because these lines have to hold 1,500 to 3,000 psi. Through these steel lines, right down here to a steel fuel rail, and then it goes down into the actual injector itself. The injector itself is not injecting on top of the intake valve like our prior systems. It's going right into the cylinder. So it has to overcome all that combustion pressure. Now, this system here works really, really well. It's very, very efficient. But there's a couple of safety precautions I have to warn you. After this point, 1,500 to 3,000 PSI of fuel pressure is dangerous. So make sure you know what you're working with. Check your service manual, check your specifications, look up the specs on how to depressurize the system so nothing happens to you if you mess with any of these fuel lines. Now, we took you through the evolution of fuel injection, but more importantly, we have to go over to the truck and diagnose one, and we'll be right back with more Tech Garage.
What result will you get from a clogged fuel filter? A. Engine running rich. B. Cooler running engine. C. Rich running engine. Or D. Lean running engine. The correct answer is D. A clogged fuel filter will result in a lean running engine and may cause higher engine temperatures, hesitation, and lack of power. This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by Advance Auto Parts. Let's get you back to the garage. AirTags, exceptional quality, unmatched support. ARP, the world leader in fastener technology. And by Race Gas, get more out of your engine. And now the email question of the week, presented by Advance Auto Parts.
John, we've got an email question here from Larry, one of our customers in Denver, Colorado. Larry's got a 2010 Camry that he said it just runs bad. He's replaced all the spark plugs, the air filter, and even the fuel filter. Still, nothing's changed. What else should Larry check?
Brian, this question works great with exactly what we're dealing with today. This looks like a fuel injection problem. Now, whether it's a Camry or a pickup truck, the theory's the same. So let's head over to the truck and test some of the systems out. Now, over here at the truck, you can see the fuel injection system starts right here. The fuel line comes in. This is the fuel rail right here. Crosses over to the other side because this is a V8. Then down here, you can see an injector. 4 injectors on each bank. And we saw earlier how it actually functions. The first thing we need to do is make sure we have fuel pressure. So I hooked up a fuel pressure gauge right here to a Schrader valve on the line. The fuel pressure gauge is going to feed pressure here. So we need to go ahead and turn on the key. And you can see the fuel pressure build. Now, once it builds, we want to let it sit for a minute, make sure it's not bleeding down. If it's bleeding down, you could have a check ball in the pump in the tank leaking, or one of your injectors may be leaking. Now, we also need to see running pressure. So if we crank up the truck, that's great. This truck had about 60 PSI of pressure. Check the specs for the vehicle you're working on, but you want to have constant pressure and you also want to have good flow. Now, if that wasn't happening, you'd go back to the tank. But if you had good pressure, you need to go down and check the injector circuit, and we'll do that next. If you suspect that the injector or the circuit's bad, I'm going to show you a few tests that a professional shop would perform, but you can perform these right in your own garage. The first one is a Noid light. Now, what a Noid light is, it's this little light right here. And what this light's going to do, it's going to simulate the injector. So I'm going to unplug the injector, plug it into this, and what the computer does, it sends a signal to open and close. That's a pulse. So when I push that in here, and we crank up the truck, you should see this light pulse. Go ahead and start the truck. Great. That's telling us that the computer's giving the injector the signal to open and close. Now, a couple other tests we can make. We need to look at the injector itself. If we were getting a pulse and we suspect no fuel's going through the injector, well, I have one right here. What an injector is, it's a bunch of windings. It's a solenoid. It opens and closes magnetically. I can actually take this here and simulate that opening. Now, you hear that? That's pulsing. Every time this is simulating the computer, it's pulsing that injector. Now, it doesn't mean the fuel's flowing through it, but at least it's opening and closing. Another test you can make is ohms of resistance. I have a DVOM here, and I set it up to ohms of resistance because there's a winding in here, and that winding has an ohm value. So I'm going to go across these two terminals on the injector itself. And you can see this one's around 14 ohms. That's perfect for this one. Every injector is a little different, so check the specifications for the ones you're working on. Now, if your injector tested out all right, you may have a fuel flow problem. Well, to check that, we can also run the test. I have a computer simulator here that's actually going to simulate the injector pulse. So what we did is we got the pressure up. The pressure's up to 60 psi right now. And because the pressure's up, I can come down here and I can hook this up to the injector. And when I hook it up to the injector, I'm going to push this button. It's going to simulate that opening. Well, if the injector opens, the fuel should go down into the cylinder. Now you can see that drop. Well, if it dropped a lot or more than any other injectors, that means it's flowing too much fuel. If it didn't drop at all, it's clogged. Now you can perform all these tests, but there's another one I want to look at. It's called current ramping the fuel pump, and that's on the other side of the truck. We'll do that next. And we're going to have to go down to the fuse panel. So I'm going to pull the fuse panel cover off, find out that it's fuse number 21. Come down here and I pull that fuse. Once I pull that fuse, I'm going to substitute it with this where I can make the connection with the meter. I put that in there and I go across that in series in amps. So the current will actually run through the meter when we crank it up. Go ahead. That's great. This one's drawn about 8.5. Think about current and resistance. If I have some mechanical resistance like a clogged fuel filter or a dirty sock, amperage is going to go up and that's going to do damage to the pump. Speaking of pumps, we have an expert coming in next that's going to talk all about fuel pumps. We'll be right back with more Tech Garage presented by Advance Auto Parts. Welcome back to Tech Garage, presented by Advance Auto Parts. Now the fuel pump, it's in the tank here, but before we take it out, we brought in an industry expert from Aerotex. Now Aerotex builds the actual fuel pumps. We have Richard here. Richard, I'm sure you hear of some concerns or some issues with these fuel pumps. Perhaps you can share with me a couple of them.
Well, one of the things we see is an electrical problem to the fuel pump. Now this can be created on the positive or negative side of the circuit. And when we reduce voltage to the pump, due to corrosion in a connector or something such as that, they'll slow the pump down and the volume of the pump reduces, thus reducing the pressure in the system.
If they have pressure loss, they could have a lean condition, the car may not run at top speeds or stall.
Absolutely. And check engine light is one of the key things that they'll see first, and they may just put a pump in, not checking the voltage or ground circuit.
Now when you get a new pump, you get a connector. I'm sure that helps the issue.
Oh yeah, with the new connector, we actually improve the contact surface of the connector, thus improves the voltage transfer.
So it's real important to put that new connector on. Don't try to put the old one on. It's a whole new configuration, isn't it?
Absolutely. And the wiring is easy. It's color to color match.
Perfect, perfect. Now to take the fuel pump out of the tank, just clean it off around here. You may have a type that has a clip on. This one's really simple. There's a ring here, so we can just spin this ring right here. And the fuel pump's located down inside the tank. You also have a float for the fuel gauge. This is going to take your fuel gauge from full to empty here. Make sure that's all intact and not bent up. And that comes with all the new one, doesn't it?
Yes, absolutely.
Now what do you find inside the tank here with corrosion? This one here is not looking too good.
I always see a big problem with corrosion, depending on the environment it's put into. With corrosion in the tank, that'll reduce the life of the pump. So if we take a new pump and put it into a tank that's not being cleaned, the pump's life will be shortened drastically.
Now we current ramped one earlier, and what we had was about 7-8 amps of electricity.
Right.
If that starts to get clogged up or the fuel filter clogged up, that's going to make the pump work harder?
Oh, absolutely. The amp draw will go up as you see those problems increase.
Because of the mechanical resistance?
Yes, absolutely.
Wow. We submerged that in gas. Why aren't we catching on fire?
Well, first off, gas does not transfer electricity. And also, because of the fuel vapor, there's not enough oxygen in the tank to sustain an explosion.
Wow, thanks. You heard it from the expert. Let's talk turbochargers and superchargers. Now, like we always do at Tech Garage, let's take a look inside. I got a turbocharger right here. On this side, It's the turbine side. The exhaust is spinning this side, and then what it does, it's attached over here to the compressor side. Now the compressor side is drawing cold air in and forcing it into the intake. Now the cool part is, this is a variable geometry turbocharger. That's some new technology. And you can see right here, if you look at these veins will actually vary. Well, think about this for a minute. If I blow through air through a tight space, that's going to pressurize the air. If I blow through this space, not so much. So at low speeds, we can go ahead and close those veins, pressurize the air, and avoid turbo lag. What's turbo lag? Well, it takes a little exhaust to get this thing spinning. And I'll show you right here on our 240 SX. It all starts right here at the turbine. The turbine's connected to the compressor. The exhaust is going to spin the compressor, and then what happens, it draws air in right through here. This is the cold air intake. And then from the compressor, it gets sent down through this tube, and it runs through this tube over to an intercooler. The intercooler is located down here, and this is going to cool the air before we send it back up and pressurize the intake manifold. Now superchargers, same principle, except they're belt driven. You can see the supercharger right here. What happens is, here's the intake side, and this is the pulley side. So if I pull it out, once again, you can see the actual rotors in here. So what's happening is these rotors spin around, it's gonna draw the air in, it's gonna send them around the outside and pressurize the intake manifold. And our GT500 has that system. Here's the actual pulley right here, belt driven. Takes a little horsepower to do it, but this thing will overcome it. Then what happens is, it goes through here, pressurizes the intake manifold. It's gonna suck in through the intake and pressurize. Now, both of these cars are making a massive amount of horsepower. We get it into the cylinders, but we gotta get it out. So next, we'll look at exhaust systems when we come right back with more Tech Garage.
A supercharged 350 cubic inch engine with 15 pounds of boost will effectively become A, 700 cubic inches, B, 400 cubic inches, C, 1200 cubic inches, or D, 500 cubic inches. The correct answer is A. A supercharger that produces 15 pounds of boost effectively doubles an engine's displacement. We'll be right back with more Tech Garage, presented by Advance Auto Parts. This edition of Tech Garage, presented by Advance Auto Parts, is being brought to you by Advance Auto Parts. Let's get you back to the garage. AirTex, exceptional quality, unmatched support. Steel Rubber, quality crafted rubber parts and weather stripping. And by Locar, quality plain and simple.
Welcome back to Tech Garage. Now you saw the supercharger and the turbocharger force air into the engine, and just as importantly, we have to get it out. And that's the job of the exhaust system. Let's start out with the muffler. You can see a muffler right here. Now what the muffler does, it takes the exhaust gases in, and it goes through a series of baffles and chambers, and then the exhaust is gonna come out the tailpipe. Now, these series of chambers and baffles determines what sound the car is gonna have. Our GT Mustang here has a high performance sound. This one would be more of a factory sound. Now we also get a lot of questions here at Tech Garage. One of them is, water's dripping out of my tailpipe or my muffler. That's totally normal, because when the exhaust goes into the catalytic converter, the byproduct is carbon dioxide and water. And you can see right here, the manufacturer actually drilled a hole right here, and what that does, it allows the water to escape out of here so it doesn't build up and rust out the exhaust system. Also, there's some hangers, there's some associated hardware. This one has a rubber grommet. We have to support this to the frame of the vehicle and stop any vibrations that the exhaust may have. Now on our GT500, here's our exhaust system right here. This is the muffler. Our muffler's right here tied into the hanger, and the hanger supports the exhaust system up to the frame and stops any of those vibrations. But just as important as the muffler is the catalytic converter. Our catalytic converter's job is to reduce emissions, and I have one cut open so we can see inside. Our catalytic converter, the exhaust is going to come in right here. Now our exhaust comes out, the byproduct of exhaust is hydrocarbons, carbon monoxide, and oxides of nitrogen, commonly called NOx. That's going to go into the catalytic converter, and it's going to go through these honeycombs, all these little chambers. Now these chambers are coated with materials like palladium, platinum, rhodium, and through a chemical reaction, out the other side is going to come that carbon dioxide and water. Also, we have an exhaust manifold. Our exhaust manifold right here you can see where it bolts up to the actual block, the cylinder head right here, and then this side is going to be our downspout. That's where it's going to come out to the catalytic converter. And we can look at it right here on our GT500. You can see right up here, this is where it actually comes to the downspout from the exhaust manifold, and then from the exhaust manifold, here's our catalytic converter, and right next to that is our oxygen sensor. And then we go back through the exhaust system to the muffler. All that's left is doing some exhaust testing. The first thing you can do, and it's a simple thing to do, is check it for leaks. Now, you can go down and get one of these stethoscopes. You can go down to Advance or any part store and get one of these. Pretty simple. Just pull off the part that checks for vibrations, put it in there, and run it along the exhaust system. If there's a leak, it'll be real audible. Right here through this hose, you'll hear it. A couple other checks you want to make, points that leak. Right here, the gasket seals this exhaust manifold to the block where the head goes. It's going to seal it right there. This is a good place to find a leak. Also, right here where the donut goes, or the gasket's going to seal this to the downspout. That may be leaking too, so check those places. Something else we can do, just get a rubber mallet. Take a rubber mallet and tap the exhaust system. This one's solid. If it sounded like this, there's some vibrations. Just check and see what's going on. It may be the media inside the catalytic converter. One of the final checks we can make is with a back pressure tester. Now, a back pressure tester is going to tell us if the exhaust is collapsed or the catalytic converter is clogged. Really simple to do. Just take the oxygen sensor out, put this in its place, and run the vehicle. If this thing starts going in the red, it's backing up pressure, you got a clogged exhaust. Now, we took a look at the car all the way from the fuel injection to the exhaust system. We're about out of time. From our garage to your garage. Thanks for watching Tech Garage, presented by Advance Auto Parts.